through 99. So anytime I write an ACL and I hang a number between 1 to 99 on a standard ACL, I know that I'm talking about standard. The most significant aspect of a standard ACL is that it filters by what address only? Standard ACL filters by?
Destination.
Source.
Hey, I was almost there.
What are you doing?
Just reading news.
You better not be playing games. You need to look at ACLs. Okay, so a standard ACL filters by source address only. Source address only. What does that mean? So, let's take a look at a situation here. Take a look at my beautiful routers. I think I have never knew that I would have the ability to be an artist. A and B and web servers right here. And I just don't want 10.0.0.0 the network to get out at all. So if I don't want them to get out, meaning I want all of their work to be done locally, and I'm only concerned with this source address and not a destination, then I can write this as access list 1. Remember, the 1 comes from 1 to 99. So this specifies that I'm dealing with a standard ACL, access list 1, followed by a permit or deny statement. Okay? Followed by a permit or deny statement. In our case here, what am I saying? I'm saying block 10 network from getting out, right? So obviously I'm interested in doing a deny. So access list 1, deny. Followed by the source address, 10.0.0.0. You following me so far? I'm saying, hey, filter my traffic and deny all IPs coming from the 10 network. So, followed by a wildcard mask. Now, the wildcard mask is telling me how many bits I'm supposed to apply this to. You with me? So, when I say 0 in an access list, that means match exactly. So here's what I'm saying with my first 0. I'm saying make sure that it comes from 10, because I have a /8, correct? So really the network that this packet is coming from is 10. The rest of them are all hosts, and I want to make sure that this ACL is applied to all the rest of them. So it's 0, 255, 255, 255. Because I want to apply it to everybody on that network. This is known as a wildcard mask, not to confuse with the inverse mask of OSPF. Okay? But it's very similar. So, if I told you that this wasn't a /8, but it is a /12, it's a /12, then my wildcard mask would be match 8. How many bits am I matching in the second octet? 4. So that's 4 on, 4 off, right? Very good. 0, 15. So I write my ACL. What's the next thing I do? The rule of thumb is, excuse me, to apply a standard ACL as close to the destination as possible. So, this is a standard ACL. I want to apply this as close to the destination as possible. I am dropping it right now. I'm going to apply it right here. Because I'm dropping the traffic. There is no reason for them to traverse my router and add traffic, right? So I go to, and this is, let's say, FA0. My next command is int FA 0/0. Once I'm in the interface, I then say IP access dash group. Access group 1, because now I'm grouping, so I can have more than one statement here. Okay? So I can have more than one statement for access list 1, and then I can group them all on an interface as I'm applying it. The next decision is inbound or outbound. Well, in this case, our traffic is flowing in, right? It's not coming out of the router, it's going into, so it's inbound. That's the standard ACL, also known as packet filtering. When we think about firewalls, we often talk about packet filtering and then stateful filtering, and we also talk about why not to use packet filters, right? Because it's the worst way to really safeguard your traffic. But this is basically a packet filter. Now, why then, if we don't use packet filtering, why then do I need to still understand ACLs? Well, because ACLs are not only used for packet filtering. When I go into reflexive ACLs, they're also used as stateful filtering, which we know is a better way of managing your traffic. But think about quality of service, where you assign priority to voice video as compared to text. So in that case, I need to use ACLs to do quality of service. So you'll find as you move forward in networking that understanding this will become important and it is applied. I just like for you to see that it is applied and it relates to your everyday work environment, so that's why we cover it and not because just want to torture you. Okay? So this is a standard ACL. Now, you need to write down some important things next to ACLs on your notes. ACLs must be written specific to general because I filter top down. When I find a match, I stop looking. What you're looking at here, and I apply it to this interface, and I don't write anything else. There is an implicit deny. There is an implicit deny, meaning, what did I just do? I just blocked all traffic. When you write an ACL and you do not implicitly then allow, you don't write an allow statement after the deny, you just blocked all other traffic. So, either you intend to deny every other piece of traffic, or you need to do what? You need to add another statement, which is access list 1 permit any. So what I'm saying is, hey, only block this one, but allow everybody else. Right? So this is very important, and often it is forgotten by administrators that, hey, if you write your ACLs and you forget about the implicit deny, you just block everybody from getting out. So I write an ACL, but I don't apply it to an interface or a line. What happens? Well, nothing happens. Why? Because it is as if you hire a traffic cop, but you never put them at the right door. They're sitting somewhere drinking coffee instead of being at the door where they're supposed to be. Okay? Because ACLs are nothing more than a cop standing at the interface of the router and saying, are you from 10000? Oh, yes, I am. Okay, well, then you're not allowed. I'm going to drop you. But what if I did it general to specific? Well, I wanted to deny this guy, but I had a general statement up here. IP access list permit IP any. It matched that. Guess what? This guy didn't get in. Do you understand what I mean? That's why you have to do it specific to general. Okay, that was a standard ACL. Now, yes. About 5 years ago. You couldn't do any of that. You couldn't delete it. You had to add it. New iOS, though, this beauty of new iOS, new packet tracer, as a matter of fact, is that you can edit it right there in front of you, because now we added sequence numbers. So we have sequence numbers in our ACL, right? And it does it like some of the old-time, well, I don't have any old-timers here. When I first learned programming, here's what we used to do. We started with the sequence numbers, and then we would go at 10 and then 20, because we knew that we would have to add more to our code later. That's what you can do with ACLs. So it has the basic idea behind it that I will start you at sequence number 10, and then the next line you write is at 20, so that if you have to make any changes, modify something, you have 11, 12, all the way to 19 to do that. Used to be, we would tell students, and as a matter of fact in industry, what we had to do is write it in a text editor and then paste it onto our routers, because you couldn't edit it. Good question, Chris. Okay. Any questions about standard ACLs? Yes. So, we know that this is specific, right? So if I told you allow everybody but this network, and you came in here and you said access list 1 permit any. By the way, any stands for any IP address. This is a general, and it will not go to the specific. Now everybody is allowed. You can't write it like that. Now, I can write it obviously where I write this statement first and then this statement second. Okay. So let's talk about extended ACLs. So extended IP ACLs have the numbers 100 to 199. And there are some more numbers at the top. I forgot. So at least 100 to 199 specifies that, hey, this is an extended ACL. As compared to the standard ACL, extended ACLs filter by source and destination IP. Remember, we only had source. Now we have source and destination, protocol, and port. So port, protocol, source and destination IP. So let's give you an example. Let's say that my web server is right here, and I also have a DNS server on the same LAN. And I want only 10.0.0.1 out of this network to be able to use DNS for zone transfer. You with me? For zone transfer, I want everybody on the 10 network, so everyone on the 10 network to use web, and I want everything else denied. Everything else denied. No other traffic allowed. If you open up your command books, kind of go to ACLs, that way some of the mistakes on there are clarified right away, so you don't have the same problem that you guys had with the book says the RIP should be configured this way. You know, it might help you out as I'm talking. So Extended ACLs